Hi everyone. So today we are going to revise our second part of chemical reactions and equation that we already studied, that how to write a chemical reaction and how to balance it. So let's start the second part of the chapter, the types of chemical reaction, and we already studied the first couple of things like a combination reaction, displacement reaction, decomposition, but even I will start from the beginning. So let's start the first one, the types of chemical reactions, and we know that you can look at this PPT. There are 5 types of chemical reactions are there: combination, decomposition, displacement, double displacement, and the last one, redox. And the redox reaction is nothing but it is a combination of oxidation and reduction that we will study later. So starting from the combination reaction. So we know that when two reactants combine to form a product is called a combination reaction. That I think examples already we done in our previous classes. So I am going little fast. Just check this. For example, calcium oxide reacting with water, we are getting calcium hydroxide. So we know it's like a simple reaction. Na? We studied A plus B gives C. So here calcium oxide reacting with water, we are getting calcium hydroxide. And I already said that what all the combination reactions are example for exothermic, because they will liberate heat energy or light energy, some kind of energy they will release. And yes, so this calcium hydroxide we are getting, and we know some nickname also. Calcium oxide is known as what? Lime or quicklime, and the calcium hydroxide is called what? Slaked lime or lime water. Now again this, look at that, calcium hydroxide reacts slowly with carbon dioxide in air to form calcium carbonate on this wall, which means this calcium hydroxide, the lime water, that again react with what? Carbon dioxide, and it will be produced what? Calcium carbonate. I think that reaction that we already know that, or if you have any, one second, that reaction if you want we will write. This calcium hydroxide, that is the lime water, so just you can just follow this. The first reaction, this one, it is written calcium oxide reacting with H2O, we are getting calcium hydroxide. So this is called what? We can know that is called lime water. Now the same lime water, you can write the calcium hydroxide. The calcium hydroxide, when we expose to carbon dioxide, we will get what? CaCO3 plus water we will be get. And this CaCO3, what is the name of this CaCO3? It is, we know that it is a white thick insoluble precipitate. PPT we can call white thick insoluble precipitate, and this is called what? Limestone. We can call it as what? Limestone. Okay, so that we know that. So that is just a continuation of this reaction. So this is an example of combination reaction. We know A plus B gives C, and most cases combination reactions are example for exothermic reaction. These are some of the examples it is given, that we know that combination reaction example, there already we written many more. Now yes, now the thing is, we know there are some exothermic reactions and endothermic reaction. We know that all combination reactions are example for exothermic. Why? Because some amount of heat energy they will be liberated. That is the reason we are calling exothermic. Endothermic later we will be discussed, because the next one is of course yes, decomposition reaction. So decomposition reaction we know just opposite of the first one, because there A plus B gives C, but here we know it's a huge compound AB. We know that AB will give what? A plus B. So, but it's a huge compound, it will be split into 2 or more. So look at, when a product breaks into its constant reaction, it is called decomposition. On example, it is given that what? FeSO4 heating we know here is what heat is absorbing, then only the reaction happening, right? So we can call that such reactions are called endothermic. Why? The reaction is carried out with the presence of heat, some amount of energy, heat, that may be electricity, that may be sunlight, that may be heat, whatever. So such reactions are called what? Endothermic. So we know that all decomposition reactions are example for what? Endothermic. This is one of the example. It is given iron sulfate, we are getting iron oxide, sulfur dioxide, and sulfur. I think this reaction is already we written. Okay, so we can, and there are the types of decomposition. I said that energy may be in terms of electricity, that is called electrolysis. We know water, we have now water, when we pass electricity, it will be produced, it will be separate hydrogen and oxygen. So here the energy is in the form of electricity, so we can call it as electrolytic decomposition, because that heat energy is what? In form of electricity, so we can call it as electrolytic decomposition. Now the next one is what? If the heat source is from sunlight, then we can call it as what? Thermal decomposition or photolysis. Okay, it is very important because the photography, that's very very important thing. The photography principle is based on the sunlight. Look at this example, it is given silver chloride. Not only silver chloride, we can also use silver bromide also. AgCl and AgBr, both are coming under thermal decomposition because the source of heat we are using from the sunlight. So look at AgCl, I think in this arrow their unit will write sunlight. We will get what? Ag plus Cl2 we will be get. Okay, and this reaction, if the decomposition reaction in presence of sunlight, then we can call it as thermal decomposition. And here also heat is absorbing, so we can call it as endothermic reaction. Okay, and the third one is, we know that is direct heating. Direct heating means the first example that what we study like this: iron sulfate on heating, calcium carbonate on heating, we are getting what? Calcium oxide, and just before we discuss. So either direct heating or electricity or sunlight. So these are the three types of decomposition reaction. Now next one is displacement. Of course, we from the 8th standard onwards we are studying what is a displacement reaction. When an element is displaced, but it's not element, we know when a highly reactive metal displaces least reactive metal from its solution, that is called what? Displacement. I think this equation is familiar. Zinc plus H2O, we know zinc is highly reactive than hydrogen, so displacement takes place. Okay, that is simple one, you know that. And even that iron sulfate, that 7th standard you study iron sulfate, sorry, not iron sulfate, copper sulfate, that blue solution we are adding iron nails, we know suddenly blue color is changed to green. That is this picture, the right side, iron nail, that activity also 7th standard you studied. Displacement reaction, you know. Just go through these examples of displacement reaction, okay, because there are highly reactive metals are displacing. So these examples already you written, just check that. Then the next one is double displacement. I think this is something new because only displacement reaction only you studied. Here it is double displacement. Double displacement is both ions are separating, both exchange. For example, the simple reaction we can call AB plus CD. AB plus CD gives AC plus BD, like that, which means both ions are interchanging. That is called what? Double displacement. So okay, for example, if you look at here AgNO3, which means silver nitrate, reacting with the sodium chloride, we are getting, look at Ag is reacting with, we know Ag is a positive metal cation, nitrate is an anion, sodium again cation, chlorine is again anion. So opposite species will be changed, right? So silver react with the chlorine, silver chloride, sodium react with the nitrate, sodium nitrate. So both exchange happening, it's called double displacement. This is the same reaction only it is given. So like there are so many examples we have that we can so many later also we can discuss in that exercise on that term there we will study. Okay, now the last types of reaction, that is a redox reaction, and I already said a redox reaction is the sum of or the combination of oxidation and reduction. Simply we can call what is oxidation. Oxidation means what? Addition of oxygen. If in a reactant we are adding oxygen, is called what? Oxidation. So reduction means what? In a reaction oxygen is removed. Removal of oxygen is called what? Reduction. So that is the general definition for what? Oxidation and reduction. But at the same time we have also another definition for both. In terms of oxygen, we can say oxidation is addition of oxygen and the reduction is removal of oxygen. But hydrogen also we can say in terms of hydrogen. So just opposite of oxygen. So oxidation means what? Addition of oxygen. But if you say in hydrogen, then removal of hydrogen is called oxidation. Understood? Just opposite. Similarly, in terms of oxygen, what is reduction? Removal of oxygen is called reduction. But in terms of hydrogen, addition of hydrogen is called what? Reduction. Okay, so both two, not only I think in your 11th standard for oxidation and reduction you will study 5 different definitions. So but this is a beginning, first time we are studying the definition of oxidation and reduction. So just go through this definition. Here you will be understood the substance gains oxygen during a reaction is said to be oxidized, and if a substance loses oxygen during a reaction is said to be reduced. And in terms of hydrogen also, look at the last sentence. If a substance gain oxygen, which means what? In terms of hydrogen, losing hydrogen. Okay, and I can look at the second sentence. If a substance lose oxygen, which means what? Gains hydrogen. So in terms of hydrogen and oxygen, we can define oxidation and reduction. So understood? Some of the examples